Good morning, everybody. It's good evening for me here, but I know it's good morning for all you guys. So I'm with the University of Florida. I work at one of the research and education centers of the university. There's about 12 in the whole state. So we're based close to Tampa on the Gulf Coast. I put a little map there in a small town called Waimama. And our focus is really vegetables, small fruits, a lot of specialty crops. So that's kind of what we focus on. I want to recognize my co-author here, Gabriele Riva. She's a master's student in my lab. She's about to graduate she's about to defend the end of this month and graduate next month. But this work was really her research project. So she really did all of the hard work. So just a little bit of history on this nematode. So it's one of the more than 100 different species of root knot nematode. It was first discovered in 1983 in South China on Hainan Island. And it was first discovered from this tree, which is called the Pacara earpod tree. And that's where it had its original name from, which was the Pacara earpod tree root knot nematode, which is quite a mouthful. So once they discovered it in Brazil in early 2000, it really ruined their guava industry, basically, and that's where it's got its current name from, guava root knot. Now, around the same time, there was another nematode which was called Mayaguensis, Meloidogyne mayaguensis, which was found in Puerto Rico in the Caribbean, which was later found in Florida, but then about 10 years ago, it was agreed upon that this was actually the same species as Enterlobi. So all the early Mayaguensis identification have become Enterlobi. So this is basically why this nematode is important. It's very prolificous, so it has a very wide host range. It's often considered to have greater damage potential than other root knot nematodes, which I'm not sure if that's quite true for all crops. But one of the main problems with this nematode is that it's able to break genetic resistance, which is available for other root knot species, but not for this one. This is the life cycle. I'm not going to go in detail, but it's really identical to any other root knot species. So you have second stage juveniles, which are called J2s. This is the stage that moves around in the soil and that will actually infect the root. So the juveniles will enter the root, develop these permanent feeding sites inside the plant, create these galls, and then you end up with these kind of pear-shaped females that produce these egg masses, which can contain hundreds of eggs per egg mass. So they can reproduce really rapidly. Species identification of root knot is not easy. It's easy to recognize root knot under a microscope, but identifying the species is a lot more difficult. In the past, we used to do these perennial patterns, and you see some on the right there of the slide, to separate the species. This is basically the butt of the female nematode, which is sliced off. It's trimmed on a slide, and then you get these kind of patterns that are kind of typical per species, but there's a lot of confusion there. These days, and the first speaker, Stan, explained it, molecular techniques are used to identify these species, and it's a lot more accurate and a lot more precise. And this was also the reason why Enterlobi and Mayaguensis at the time were confused, which was really based more on morphological than molecular data. So right now, this nematode is pretty much distributed worldwide. So Australia was the only continent until recently where it hadn't been discovered. But if you look at the world map, it's really a subtropical nematode. So it's really, currently, it's really found in all the tropical regions across the world now. And there's more and more reports every week or month, at least. I see another report right now. Recently, they found it in Egypt, which was the first time they found it in North Africa. It's common in the rest of Africa, but now they also found it in Egypt. So you know, it's really a fairly really common tropical root knot species, I would say. In the US, it was first found in 2001. At that time, it was called Mayaguensis still on ornamentals. In 2013, it was found in North Carolina, which is a big sweet potato producing state in the US. So that's a big concern there for the sweet potato growers. 18, it was found in Louisiana, but I don't believe it was found in a field. I think it was found in a shipment to Louisiana from Florida, where they found the nematode. But more recently, they have found it in South Carolina in a field as well as in Georgia. And of course, the problem is now that a lot of states, southern states in the US are putting out quarantines for this nematode. So the project that we're working on for the past years, it's called the Find Me project, which stands for Focused Investigations on the Distribution and Management of Maloidogine Enterlobi. It's a multi-state, it's a federally funded project by the United States Department of Agriculture, and it's really focused in these 5 states that are mentioned here, the Southeast. So our project, our part of the project was really focusing on distribution and management of this nematode in mostly South and Central Florida. So this is basically how we did, the survey. We looked at commercial farms. We looked at a lot of the research farms, whether it's academic or private, horticultural gardens. So this is like little community gardens, which are quite common here. And we took a few samples also from natural landscapes. So it was really focused sampling. We looked for symptomatic plants in the hope of finding galled roots. If we found them, we collected about 3 to 10 galled roots, depending on the size of the fields, collected the GPS coordinates, and then stored it in a cooler for DNA extraction. This is just a process. We typically collected 3 females per root system, extracted the DNA, and then used the primers to identify whether it was Enterlobi or not. If it was Enterlobi, we also send it out for sequencing. As part of what we're trying to do in the project is also do some phylogenetics and see how diverse this group of Enterlobi is. So this is what we found. 247 samples were positive for root knot, and we were kind of surprised that Enterlobi was just as common as incognita in samples that we collected in South and Central Florida. So in the past, it was always considered that incognita and javanica are the most common species in Florida. But, it turns out, at least in the fields that we sampled, Enterlobi was just as common as incognita. We also found some arenaria. We have some hapla that's mostly in our strawberry fields. And then we have some fields, obviously, also where there's some mixed infestations. So as far as the crops, like most root knots, Enterlobi has a very wide crop range. We found it on 20 different crops. A lot of them were peppers, so they really seem to like pepper. M. incognita, we found it a little more common on the tomatoes, just as javanica is. Arenaria was a little more common on ornamentals, and as I said, hapla was mostly found on strawberries. This is just some pictures from some fields where we found Enterlobi. So this is some severe damage on tomato on the left, and really severe galling, as you can see. Similar on pepper, we see a lot of stunting, yellowing, chlorosis of the plants, and also for pepper, quite severe galling with Enterlobi. If it's incognita, typically the galls on pepper tend to be a little smaller. This is Lufa, a cucurbit crop, again, severe galling. But then there's some other crops where we found Enterlobi. It's quite symptomatic, like here you see Thai basil, but the galls were really small. So the severity of galling is really crop dependent, not just species dependent. This is some other pictures. We found it on sweet potato. We found it on pumpkin, water spinach. So we have a lot of Vietnamese growers in our area that grow a lot of Asian vegetables, for the whole US market, New York, Chicago. And they grow a lot of crops like, spinach, water spinach, ginger. And we found, especially these farms, Enterlobi was very common. So we found it on ginger and jute as well. And you can see on some of these crops, the galls are really not that extensive or that big as in some other crops. So as far as management, we always try to advocate an integrated approach. Most growers here still rely largely on chemicals, but we also try to introduce some biological control, cultural control, and resistant cultivars. Now, as I said earlier, this is one of the main issues with Enterlobe, with guava root knot, is that the existing resistant cultivars that we have for root knot, whether it's in tobacco, tomatoes, soy, potato, sweet potato, cotton, cowpea, they work against these three species of root knot, but they will not protect against Enterlobe. So that's one of the main issues, and that's why a big part of our project is to try to develop germplasm with resistance to guava root knot. And this is one of my colleagues with the USDA in Charleston, South Carolina, Will Rudder, as the focus of his program. He's looking a lot at sweet potatoes, a lot of cucurbits like watermelons, cucumber. I know he's made some good progress in sweet potatoes. Watermelon seems to be a little harder. Other things as far as management that we're doing is look at chemical control options, look at cover crops, rotational crops, and of course also containment and sanitation measures. This is just a list of chemicals that we work with. I'm not sure what you have available in Australia at this time. Most of our vegetable growers still will fumigate their fields. We still have talon, 1,3-D, methane-based products, chloropicrin, so often mixtures are used. Oxamyl vidate is still a fairly decent nematicide in vegetables. And then we also have these two new products, fluorosulfone, fluoparan. I color-coded them green because they're a lot safer to use. They just have a caution label, unlike these older nematicides, which are quite toxic. And then some two new ones, which we don't have registered yet here, but they should be coming on not too far along, is fluazine and cyclobrifluoram timerium. So this is a Syngenta product. The previous one is a Corteva. I think you might already have Celebro in Australia. I'm not sure. But yeah, it's coming in the US too. So these are some products we looked at. Honestly, we haven't seen much difference in sensitivity of any of the root knot species. So if any, like the fumigants, they work just as good against Javanica as they work against Enterlobe. And even with these non-fumigant nematicides, we haven't really seen much difference in intrinsic sensitivity of the nematode. We looked at cover crops too, and we're doing a lot more work on that at the moment. But this is just some data of reproduction factors. So the higher the number, the more the nematode reproduces on these cover crops. So we looked at those 4 species of root knot, Javanica, Incognita, Enterlobe, arenaria, which are common in our state. And you can see sun hemp, which is Crotalaria johnsia, very common cover crop here in Florida, grows really fast, really well. It's really a good option when you have any of these root knot species, because we don't really see any reproduction. Sorghum Sudan grass is another option. It looks good for Enterlobe, but things like sunflower, cowpea is not a good idea when you really have any of the root knots, but certainly not Enterlobe. You know, they pretty much look similar to tomatoes, so very, very high reproduction. So right now, what we're recommending as far as cover crops to growers is do a sun hemp, sorghum, or a mixture of those. We also developed some educational materials. So this is just some one-page fact sheets that we developed. We have them in English, we have them in Spanish, we have a lot of Spanish-speaking growers here, and we also made some in Vietnamese to kind of get to the Vietnamese growers where we find a lot of this nematode. So in summary, you know, we were kind of surprised. Enterlobe seems to be a lot more common in Florida than previously thought. Probably it was often misidentified as Incognita, I believe. And this makes us think that we actually found it in a natural area too, where there's never been any agriculture. So we're thinking that maybe this nematode might be native to Florida, might have been at least here a lot longer than we think. Has a wide variety of hosts, so it's a very broad host range. It's likely being spread with plant soil material. I think that's what's happening in a lot of these Asian vegetable farms. They exchange a lot of plant materials, tubers, rhizomes, seedlings. As I said, management is pretty similar to other root knot species, except the use of resistant cultivars. This is, of course, the big deal with this nematode. As far as impact on vegetable growers, for the sweet potato guys, it's mostly the quarantine restrictions now they have to deal with. and of course the inability to use any of the resistant cultivars. As far as reducing risk, it really comes down to monitoring fields, to monitor plant material. So, I'll be really interested to see also in Australia, is that nematode, are you going to find it a lot more? So maybe it's been there a lot longer than you think, and the introduction may not have been that recent. If I look at the global map of Amenterlobia, it's pretty much common across all the tropics. So, which makes me wonder, like, has it been there all along and just misidentified in the past because nobody was really looking for it? I think those are some of the questions that'd be interesting to answer. And that's all I have. So, you can find some more information on the website there, the Find Me website, or you can send me or Gabriele an email, and we'll be glad to answer any of your questions.